Part 2 of Lesson 2. So we're going to again be talking about end behavior and multiplicity. So the multiplicity, I think that's a fun word to say, of a factor of a polynomial function is the number of times a related binomial factor is repeated in the factored form of the polynomial. So here's an example. If the equation of a function in intercept or factored form, it looks like this. The multiplicity at x equals 4 is 2. So here I know for this little part, x equals, when the function is 0, x equals 4, and the multiplicity is 2. So if the multiplicity where x is -7, which would be this one, the multiplicity is 3 because it's repeated 3 times. If we expanded that, it would be f of x equals x minus 4, x minus 4, x plus 7, x plus 7, x plus 7. Okay, so you can see that it's multiplied, its multiplicity is 2, its multiplicity is 3. The turning point of a graph of a function is when the concavity of a curve changes from positive to negative or negative to positive. In other words, it's a maximum or a minimum. And you need to know that the maximum number of terms that a function can have is 1 less than its degree. So if I have a function that is something like this, I know the degree is 7, so the maximum number of terms is n minus 1, where n is the degree, so it would be 7 minus 1, which is 6. In English, what all of this means is multiplicity is a fancy word for the number of times any given zero repeats itself in a solution. So what is the multiplicity of -1 in this function? This is the factor that has -1 as a 0, because to find it, I set that factor equal to 0, so x equals -1. It's repeated 4 times, so the multiplicity is 4, which is even. Okay, a turning point, it's a vertex, minimum or maximum point. So what is the maximum number of turning points for a function of degree 7? And so the maximum number is basically if the degree for degree equals n, the maximum turns is n minus 1. So here, if it's a degree of 7, it means the max turns would be 6. For degree of 3, the max turns is 2. And degree of 1, the max turns is 0. Think about it. If you have a degree of 1, it means your f of x is something like this. And that's just a linear equation. And how many turns are in that line? None. So 0 turns. What do you know about this function just by looking at it in intercept form? In intercept form, again, is another word for factored. So it's in its factored form. I can look at my factors. They are x plus 3, x plus 2, and x minus 1. And I've listed them from right here. Okay, to find my zeros, I set each one equal to 0, so I know that x would be -3. If x plus 2 equals 0, that means x is -2. And if x minus 1 equals 0, then x is 1. So here are my zeros. So now I look at the multiplicity. How many times is the factor x plus 3 repeated? It's repeated twice. So the multiplicity is 2, which is even. How many times is the 0, -2 repeated? And it's understood to be a 1 here, so 1, which is odd. And how many times is 1 repeated? The 0, 1, and that is 3, which is odd. So then I can talk about my x-intercepts. I know that zeros are almost synonymous with x-intercepts, but when we're talking about x-intercepts, you need to give it in ordered pair form. So the ordered pair would be -3, 0, -2, 0, and 1, 0. And what that means is whatever this function looks like, it's going to cross the x-axis at -3, at -2, and at 1. We know that those are 3 points that satisfy this function. Okay, let's see what we know about this function just by looking at it. I identified my zeros by setting each factor equal to 0, and you can see this is at -3. It crosses. At -2, it crosses, and at 1. Okay, I also know because it's going up, up, I know it has even degree. Well, let's talk about the degree of this polynomial. If I add these exponents, so I'm adding 2 plus 1 plus 3, that equals 6. So I know the degree of this polynomial is 6. And if I expanded this out, this entire thing out, and used FOIL and multiplied it, the highest power would be an x to the 6th. And my lead coefficient would be 1. So I could also talk about in behavior, because in behavior, as x approaches -infinity, f of x approaches positive infinity, and as x approaches positive infinity, f of x approaches positive infinity also. I also see, let's look at the number of turns. Okay, it has a turn here, 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 so that's 3, 4. And I really wouldn't call this a turn because it continues just to kind of increase. There's no real turn from being a positive to a negative. So the number of turns is 1, 2, 3, 4. When I gave you n minus 1 for the number of turns, it was for the max turns, not how many turns there actually are. So this one had a max turns of 5 because the degree was 6. So the max turns was 5, but it actually only had 4. One other thing that I want you to take note of about this graph is what happens at the x-axis with each one of these factors. So here we say that the graph touches the x-axis. Here it crosses it, and here it crosses it. You'll start seeing a pattern that when it touches it at -3, so at this factor right here. And notice that -3 has an even multiplicity. Notice that at both places where it crosses, the multiplicity is odd. And this will help you graph functions using the multiplicity. Okay, this is a very large problem, but it'll put a lot of things together for you. So it's all in your notes, and so take a few minutes to fill in as much as you can in your notes, and then come back to the video and see what you got correct. Okay, here are the answers that I could get just by starting out by putting the function in my calculator. And then notice that I also found it handy to actually factor it. That helped me some too. I know by my zeros where they're going to cross the y or x-axis. And I also know by the multiplicity that when the multiplicity is odd, I know it crosses. And so for each one of these, I know it's going to cross through the point, not touch it. I also know that since it's odd, normally an odd starts down and then does whatever it does and ends up. But since my lead coefficient is negative, I know it's going to be the opposite. So I know this time it's going to start up, do whatever it does, and end down. So I know it's going to start up. I know it's going to go through, pass through -2 and go to my minimum, which was -1.155 and 3. So I'm going to estimate that point, and I'm going to go ahead and put in my maximum also. That was 1.155 something, and it goes up to 3.0. So my multiplicity at -2 again was 1, so it's odd, so I know it crosses through, it's going to go down, and that go to my minimum, then go back through, cross through the 0, 0, go up to the maximum, oops, didn't quite reach it, and come back down. It is an odd function, so it makes sense that my end behaviors will go in opposite directions.